Okay, so to do this quiz trade activity, you are probably going to want to have that sheet you just filled out on your desk. And so I'm going to have you guys go ahead and get in your groups of like 3 or 4. So like 4 groups of 3 or 4 people. Um, and so you probably have people you get with when I say this. So go ahead and get in those groups. One person in your group needs to have a piece of paper. So you guys do that. Pause the video, and then I'm going to explain how we're going to do this. All right, so whoever has the paper, label it 1 through 21. And I am going to do 4 of these with you. And then I'll explain what I want you to do after that. Okay, and so this is number 1. And it tells you that the graph of f of x is shown. So these graphs are either going to be f of x, f prime of x, or f double prime of x. So first thing you need to do is make sure you read that so you can get in the right frame of mind, and then you'll know where to look on the table. All right, so this is f of x, and we want to know on which intervals is f prime of x positive. Okay, so we're looking at the relationship between f of x and f prime of x, which we do have some information here about that. But for what we're looking for here, we want to go to that top table. All right, so for f prime of x to be positive, which is this right here, greater than 0 is positive, then f of x needs to be increasing. So if we look back at the graph, f of x is increasing, which is what this graph is on this interval right here and on this interval right here. All right. And so on your paper, please don't write on the cards because we're going to use them the other class, second class, second period class to use, and then I'll probably use them again next year. So anyway, when we're given these intervals, of course, we're going to use x values. And so this function starts increasing at this x value right here, which tells us is negative 1.225. And we're going to increase until we get to this x value right here, which is positive 1.225. So that's one of the intervals where f is increasing, so f prime is positive. The second interval starts at 3, x is 3, and increases forever to the right, and forever to the right is infinity. All right, so let's look at number 2. For number 2, we have the graph of f prime. Okay, so we have to think a little differently. So the graph of f prime is shown. For which x values does f of x have a critical point? Okay, so for a critical point, we're going to go to this top chart. A critical point is when f prime is either 0 or undefined. All right, so f prime, which is what this graph is 0 at -3 and 3, and undefined at 2, because I have that open circle there. So those are the critical points. If we have the graph of f prime, we're looking to see where the graph is 0 or where the graph is undefined. Okay, number 3, we have the graph of f prime, and we want to know on what intervals is f of x concave down. Okay, so let's look at our tables and see where we're going to get this information. So this top table is talking about f and f prime, but this is mostly about increasing and decreasing and relative max and relative min. If we're looking about concavity, we're going to need to look at the second table. Okay, so and it's kind of weird because I don't know if we've kind of thought about this before, but there's a relationship between f prime and f. just like there's a relationship between f double prime and f in terms of concavity. So if we want concave down, we want f to be concave down, so that means I need f prime to be decreasing. Okay, so let's look back at this graph. All right, this is the graph of f prime. F prime is decreasing on this interval and then again on this interval. All right, so as far as we can go to the left, f prime is decreasing, so that's negative infinity until we get to this point right here where x is negative 1.206. All right, and then decreasing again when x is 1.399 and then stops decreasing when x is 3.577. So that was this interval right there. Okay. All right, let's look at number 4. The graph of f double prime is shown. For what values of x does f prime have a relative minimum? All right, so for f prime to have a relative minimum, then f double prime needs to change from negative to positive. All right, so when we're looking at number 4, f double prime changes from negative to positive 2 places. So this is the second derivative graph. We're negative here, it changes to positive when x is negative 3, right? And then it happens again for here. So we're f double prime is negative, f double prime is positive also when x is 5. I'm gonna erase that comma just because it looks like an ordered pair and I don't want it to. So that should be a relative minimum for the first derivative when the second derivative changes from negative to positive. All right, so this is what I want y'all to do. I want Mr. Bingham to give each group a little set of cards. So it's your set is going to have either 4 or 5 cards in it. All right, and then wherever you are on your list of 1 through 21, write down the answers. So the graphs are all labeled with numbers 1 through 21. Right. See if you can figure the answers out together. Then check your answers and see. Hopefully you got it right, but if not, see if together you can figure out what's going on. All right, and then when you guys are done, turn your papers in. Make sure the whole group's name is on your paper, and then you have a sheet to work on for your homework assignment.